Hello everyone, welcome to Chemistry Academy. Today I am going to discuss the first problem of Olympiad series, and in this session from time to time whenever we are going to get some appropriate time, we are going to discuss question based on Olympiads which will help you to bring your rank to an upper level by solving questions based on different topics. So nowadays in JEE Advanced, this type of pattern is coming where they will mix different topics and make a very good problem. Before starting this series, I will like to share about our achievement in this year. In 2023, we are lucky that with the grace of God, we got AIR 1 in JEE mains. That is Venkat Kondinya. He's a very grounded student and very disciplined. Then in JEE Advanced result, which is coming on Sunday, we are going to get 4 students in top 25. There are 2 students expected in top 10, Surya Teja and Abhinav Chaudhary. Apart from that, Venkat Kondinya is also expected in top 25. And apart from Venkat Kondinya, another student is there, Gyan Kaushik. So we are expecting 4 students in top 25. So this is a very good result for a teacher. Teaching a student like this is an achievement and we'll like to share with you. In 2018 also we got 3 students in top 10 when we are in Chena batch, when we are in Chena, where we got rank 4, rank 5, and rank 8. This year we have started our online channel, right? So our YouTube channel, through our YouTube channel, you can get these videos of JEE Mains, JEE Advanced, and Olympiad. But apart from that, we have an application also. So I would like to share about my app with you. So let me share the information from our YouTube channel. So before starting problem number 1, which is based on Henry law, thermodynamics, and ionic equilibrium, I would like to share some information about our channel. So if you go on our YouTube page and you will find that here there is a Telegram group for discussion. So if you have any problem regarding chemistry, you can message here and there are a student, they can answer, and if they will not able to answer, will answer your query here. Apart from that, there is an app. So if you click here, you will go directly to our app where you can download the app and get free JEE advanced test papers along with their answers. And whatever this Olympiad series I am going to discuss, the discussion PDF will be available free on this app. So please download our app and get the things available free on that. If you want to join any course, the details are there in the app. You can join it. So let us discuss another way to go to our app. You go in our channel and then in about you can find out. If you click about and then you'll get the links, right? So there is a link for our application. When you click this application, you are going to get this type of app, right? So here there is a picture of app, right? Chemistry Academy se bahut sari app ho sakti hain, but this is our app. So from here, this way also you can do it. So let us start Olympiad series problem number 1. All of you know that in Olympiad series, you can use calculator. Calculator is allowed. So here the calculations are difficult, and I have taken one question from Olympiad and I'm discussing it. So there are 4 parts in this question, and already discussed that this question is related to 3 concepts: Henry law, thermodynamics, and ionic equilibrium. So here is the question. The concentration of carbon dioxide in the atmosphere has increased substantially during this century, and this predicted to continue to increase. The carbon dioxide is expected to about 440 ppm, that is 440 into 10 to the power minus 6 atm in the year 2020. So this question has been framed long back. right? So 2020 pass out ho gaya hai, but yes, the question is related to it. Calculate the concentration in mole per decimeter cube. Decimeter cube means liter of carbon dioxide dissolved in distilled water equilibrated with the atmosphere in the year 2020, right? So let us try to solve this question. This is a simple problem. Some data is given here. The Henry law constant for carbon dioxide at 298 Kelvin is 0.0343. The unit mentioned here is wrong, so I have corrected it. It is mole per decimeter cube per atm. Thermodynamic values in kilojoule per mole at 298 Kelvin are given. So here there is delta G naught formation and delta H naught formation, and we know that for H plus ion at 298 Kelvin, delta G naught formation as well as delta H naught formation is equal to 0. Apart from this delta G naught formation and delta H naught formation, entropy of H plus ion, S naught, standard entropy of H plus ion at 298 Kelvin is also assumed to be 0. So this problem we can solve here by using Henry law, but see here there is a difference in the way they have framed Henry law with our NCERT, right? So in our NCERT, when we are talking about Henry law, we are saying that the pressure of the gas is equal to the Henry constant into the mole fraction of the gas in the solution, right? So this is given in NCERT, but now in this Olympiad problem, if you see the unit of Henry constant, because here the unit of Henry constant is that of pressure, right? So it may be in atm. If the pressure is given in atmosphere, the unit of Henry constant is equal to atm. This mole fraction is unitless, but here if you see the value of Henry constant is given, and Henry constant की वैल्यू क्या दे रखी है इसमें 0.0343. Units are given wrong, so there is a correction. Mole per liter means per decimeter cube per atm. So you can see here that if pressure will be on this side, then only the unit of Henry constant will come in per atm, right? And mole per liter means in place of pressure of the gas, if I write here what is the Henry law, the Henry law is represented in this form. The concentration of carbon dioxide is equal to the Henry law constant into the pressure of carbon dioxide. From here you can match that this unit should match here. So the unit of concentration of carbon dioxide will be mole per liter, and pressure is in atm. So from there you are able to match the unit of Henry constant given over here, right? So now if this is the Henry law, I can use the definition of ppm, parts per million. So the ppm value is given, that is equal to 440 ppm for carbon dioxide. That can be defined as the pressure, partial pressure of carbon dioxide upon total pressure. Since carbon dioxide is present in atmosphere, so the pressure of atmosphere into 10 to the power 6. If nothing is mentioned about the pressure of atmosphere, I will take the normal pressure as 1 atm, and then I will find out that what is the pressure of carbon dioxide here. So from here I can write that the pressure of carbon dioxide is equal to 440 into 10 to the power minus 6 atm. And that is given in the question also, right? So they are saying the concentration is expected to be this, and in terms of pressure they are writing. So in terms of pressure, if you write that the pressure of carbon dioxide is this. Now if I put the value of pressure of carbon dioxide over here and Henry constant, I can calculate the solubility of carbon dioxide in mole per liter, mole per decimeter cube. So the solubility of carbon dioxide is Henry constant. The value of Henry constant is 0.0343 into the pressure. The value of pressure is equal to 440 into 10 to the power minus 6. We can further simplify, and calculator is allowed here. So I will use calculator to solve this. So 0.343 into 44 into 10 to the power minus 6. If you see in this, the significant figure in this is equal to 3, and the significant figure in here is also 3. So while writing the answer, I should first multiply it. 0.343 into 44 is equal to 15.092 into 10 to the power minus 6. If I want to write the answer in scientific notation, it should be 1.5092 into 10 to the power minus 6 capital M. While writing the final answer, if I try to write exactly, I have to use up to 3 decimal place only. So 3 significant figures I should use. तो इसको राउंड ऑफ करेंगे तो दिस वैल्यू इज इक्वल टू 1.51 into 10 to the power. Here it will be this should be minus 5. So this value is equal to 1.51 into 10 to the power minus 5 capital M. So this is the answer of 1.1 part, where the molarity of carbon dioxide is 1.51 into 10 to the power minus 5. तो इस क्वेश्चन को करने से आपको क्या फायदा हुआ, क्योंकि जेई एडवांस में ज्यादातर एनसीईआरटी को फॉलो किया जाता है, लेकिन आप अगर स्टैंडर्ड बुक्स को पढ़ोगे तो कई जगह हेनरी लॉ को हम डिफरेंट फॉर्म्स में लिखते हैं. तो अगर कुछ मेंशन नहीं है, आपको सबसे पहले यूनिट चेक करनी है हेनरी कांस्टेंट की. इफ दे आर फॉलोइंग एनसीईआरटी, दे विल यूज द यूनिट एज यूनिट ऑफ प्रेशर. तो अगर प्रेशर की यूनिट है हेनरी कांस्टेंट की, इट मींस दैट वी आर राइटिंग द हेनरी लॉ इन दिस फॉर्म. But here in this question, by looking the units of Henry constant, we have decided that how to represent the Henry law. So this is an important point which you have learned from this question. So let us move to the second part of the question. So in the second part of the question, they are asking that calculate the pH value of the solution. So we have dissolved carbon dioxide into distilled water, and we want to know that what is the pH of the solution. So in order to calculate the pH of the solution, you have to go through this data, because you know that carbonic acid in ionic equilibrium, you have studied that it is a dibasic weak acid, first dissociation constant and second dissociation constant. But here, if you see the information, there is no delta G naught formation for carbonate ion. Only bicarbonate ion, H plus ion, and carbon dioxide dissolved in water is given, and water gives free energy is given. So this data is telling something that how to proceed. So data is telling that you don't have to consider the second reaction. And when we have solved the questions of ionic equilibrium, we know that the primary source of H plus ion in carbonic acid is the first reaction, right? So here from the data, we can conclude that we have to take this reaction. Carbon dioxide dissolved in water is reacting with water. So CO2 in aqueous state plus H2O in liquid state. And on dissociation, it will form H plus ion in aqueous state plus bicarbonate ion in aqueous state, HCO3 minus ion in aqueous state. So this is the reaction. From this reaction, since they have given the value of delta G naught formation of all the reactants and all the product, delta G naught formation of carbon dioxide in aqueous state is minus 386.2. Delta G naught formation of H2O in liquid state is minus 237.2. And delta G naught formation of H plus ion is 0. Bicarbonate ion delta G naught formation is minus 587.1. So for this chemical reaction, if I want to calculate what is delta G naught of the reaction, delta G naught of the reaction can be written as summation delta G naught formation of product with their stoichiometric coefficient minus summation delta G naught formation of reactant with their stoichiometric coefficient. So here the reactant and product, all the reactants and product have a stoichiometric coefficient of unity. So now if I put the value that what is delta G naught of the reaction, delta G naught of the reaction is equal to delta G naught formation of product. So here it will be minus 587.1 minus and minus will become plus. So this is equal to 386.2 plus 237.2. So by using calculator, if I simplify this, minus 587.1 plus 386.2 plus 237.2. So on adding these three, I'm getting that delta G naught of the reaction is positive and that is equal to 36.2 kilojoule per mole. Delta G naught of the reaction is positive. It means that the value of equilibrium constant, since this value, you can see here that this value is positive, equilibrium constant will be less than 1. So in order to solve the value of equilibrium constant, I can use this relation that delta G naught of this reaction is equal to minus 2.303 into R into temperature log equilibrium constant. So here the base, because I have used 2.303, so log base will be 10. So now if I simplify, if you follow NCERT में आप अगर 11th क्लास की NCERT में थर्मोडायनेमिक्स चैप्टर है, वहां पे आप पीछे देखोगे तो कुछ वैल्यूज दे रखी हैं जो कि हमारे लिए इंपॉर्टेंट हो. इन NCERT they have given this value. We are using in JEE advanced preparation also, that 2.303 into 8.314 into temperature is 298 Kelvin. So अगर हम इसको multiply करें, so this value is directly given in NCERT. You can use calculator also if you don't know, but ये value आपके JEE advanced के लिए important है. That's why I'm mentioning here. This value is 5709 joule per mole. So by using this data, I can write that delta G naught of this reaction divided by, यहाँ माइनस साइन लगा देते हैं, 5709. Delta G naught we have calculated. Delta G naught is equal to 36.2. I think I have written here 36.6 is coming. If you do calculation, you are getting delta G naught formation as 36.3, sorry. So this value is coming 36.3. So now if I put the value over here, I can write that this value is equal to 36.3. I have to write in joules, so I will multiply this by 1000 divided by 5709. So by calculating this value, I am getting that this value is equal to minus 6.36. And that is equal to log base is 10 equilibrium constant. So from here, if I write that value of equilibrium constant, that what is the value of equilibrium constant, and this equilibrium constant is Kc because all the reactant and product are in aqueous medium. So this value Kc is equal to 10 to the power minus 6.36. If I further want to simplify, I will add plus 1 and minus 1. By doing that, this can be written as 10 to the power minus 0.64 into this will be plus 0.64 into 10 to the power minus 7. If minus 6 and minus 1 will be minus 7, 1 minus 0.36 will be 0.64. तो इसको अगर हम सिंप्लीफाई कर रहे हैं तो Kc की जो वैल्यू आ रही है, द वैल्यू ऑफ Kc इज इक्वल टू 4.36 into 10 to the power minus 7. So this is the value of dissociation constant Ka of the acid. Ka की वैल्यू हमें पता है. Now for the reaction that carbon dioxide in aqueous state plus H2O in liquid state will form H plus ion in aqueous state plus bicarbonate ion in aqueous state. Initially at time t is equal to 0, its concentration we have already calculated that what is, by using Henry law, we have calculated that what is the concentration of carbon dioxide. So this is C naught, 1.51 into 10 to the power minus 5. So here in place of writing 1.51, I am writing this is C naught. This is solvent, so this is present in excess amount. So at equilibrium, if I write, this is equal to C naught minus X. Here it is X and X. So the value of equilibrium constant, that is dissociation constant Ka of the acid, which we have calculated 4.36 into 10 to the power minus 7, is equal to X square upon C naught minus X. Right, the value of C naught is 1.51 into 10 to the power minus 5. Right, we have calculated this value 1.51 into 10 to the power minus 5 molar minus X. I cannot neglect X with respect to this value, because if I neglect and solve, right, this can be neglected if this value is less than 5% of this value. So if you simplify, you will find that you are not able to neglect it. So we have to solve the quadratic equation. If I solve quadratic equation, I can write that x square, इसको क्रॉस मल्टीप्लाई करते हैं और राइट हैंड साइड में ले जाते हैं. सो आई विल राइट प्लस 4.36 into 10 to the power minus 7 into x minus 4.36 into 1.51 into 10 to the power minus 12 is equal to 0. If I solve this quadratic equation, I can write that x is equal to minus b means minus 4.36 into 10 to the power minus 7 plus b square. B square means 4.36 into 10 to the power minus 7 whole square minus 4ac. So minus and minus will become plus because here c is negative. So 4 into 4.36 into 1.51 divided multiplied by 10 to the power minus 12. In order to convert into 10 to the power minus 14, I am dividing and multiplying this thing by 100. तो 100 से इसको divide और multiply कर देते हैं. Right, so this will become 10 to the power minus 14. So divided by 2a, a is equal to 1. So this is equal to this value. If I simplify this value, अगर मैं इस value को simplify करता हूँ with the help of calculator, will able to simplify this value. So on simplification, I am getting that this value is equal to 2.18 into 10 to the power minus 7. ये तो आपको यहाँ से दिख रहा है कि अगर मैं 4.36 into 10 to the power minus 7 कॉमन ले लूं इसमें और इसमें और उसको फिर 2 से डिवाइड करूं तो 2.18 into 10 to the power minus 7 आएगा. ये जो ब्रैकेट में चीजें हैं इनको अगर हम सिंप्लीफाई करते हैं, दैट वैल्यू इज कमिंग 10.77. So on further simplification, we are getting that the value of x की जो value आ रही है वो आ रही है 2.35 into 10 to the power minus 7 और x का मतलब है H plus ion concentration. So if we know that H plus ion concentration is 2.35 into 10 to the power minus 7, by taking minus log on both sides, I can write that pH is equal to 7 minus log 2.35. So here log 2.35, if we calculate, that value is 0.37. So 7 minus 0.37. So from here we are getting that pH is equal to 6.62. So 6.62 is the pH. This is the answer for the second part. So it is a lengthy, but with the help of calculator, you can do it, right? So this is about 1.2 number problem. Now 1.3, calculate the enthalpy of reaction between CO2 in aqueous state and H2O. So this is a very simple problem. We first write the reaction CO2 in aqueous state plus H2O in liquid state will form H plus ion in aqueous state plus bicarbonate ion, HCO3 minus ion in aqueous state. So here they have mentioned that what is the value of delta H naught formation of all the reactant and all the product. For carbon dioxide, the value is minus 412.9. For water, the value is minus 285.8. For H plus, it will be 0. For bicarbonate ion, it is minus 691.2. So in order to write what is delta H naught of reaction, I can use the formula summation delta H naught formation of product with their stoichiometric coefficient minus summation delta H naught formation of reactant with their stoichiometric coefficient. So in this reaction, all reactant and product has the coefficient 1, stoichiometric coefficient 1. So we can directly write the value that delta H naught of this reaction is equal to delta H naught formation of product minus 691.2. This minus and minus will become plus. So 412.9 plus 285.8. So if I solve this value on solving, minus 691.2 plus 412.9 plus 285.8 is equal to 7.5. So 7.5, and all the things are given in kilojoule. So kilojoule per mole. So this is the answer for question number 1.3. It is an easy question. Now the next question is, if the temperature of an equilibrated solution of carbon dioxide is increased and concentration of dissolved carbon dioxide is maintained constant, because we know about the solubility of gases, if you increase the temperature, solubility is going to decrease. But they are saying that we have maintained the concentration of dissolved carbon dioxide same. The pH of the solution will what? So from here we got that this is an endothermic reaction. Delta H naught reaction is positive. So since delta H naught reaction is positive, for endothermic reaction, we have studied that variation of equilibrium constant with temperature, ln K equilibrium 2 upon K equilibrium 1 is equal to delta H naught upon R T2 minus T1 upon T1 T2. So if I am saying that T2 is greater than T1, means I am increasing the temperature. So this whole thing is going to be positive. If it is endothermic reaction, delta H naught will be positive. So from here I can say that in case of endothermic reaction, on increasing temperature, equilibrium constant will increase. So we can say that on increasing temperature, equilibrium constant Kc for this reaction is equal to concentration of H plus ion into concentration of bicarbonate ion, HCO3 minus ion upon concentration of carbon dioxide. because water is pure, so its activity is equal to 1. So this is the formula for Kc of this reaction. In this, they are saying that the concentration of carbon dioxide is maintained constant. And we know that Kc is going to increase. If Kc is increased, it means that H plus ion concentration is going to increase and bicarbonate ion concentration is also going to increase. So if H plus ion concentration is increased, we know that pH is inversely proportional to H plus ion concentration. pH is minus log H plus ion concentration. So if pH is going to increase, H plus is going to increase, we can say that pH is going to decrease. pH will decrease for this reaction. I hope that from this problem of Olympiad, you benefited somewhere regarding Henry law in thermodynamics. 2.303 into R into 298 is equal to 5709, which we can use and save the time. In the coming months, we are going to discuss these type of problems. Sometimes we'll discuss about Olympiad, sometimes we'll discuss about JEE Mains and JEE Advanced also, right? So keep in touch and please share about our channel with your friends and circle. And don't forget to like. Thank you very much.